Okay, welcome. So here's the theorem that follows from the last video, so from the work that I showed you on the board. So the theorem says that finding the area between two curves is given by this information. And this is kind of like a rehash of what I was showing you in the last video with the Riemann sum and taking the limit of that. It says, so this is the result. Let f of x and g of x be continuous such that f of x is greater than or equal to g of x over the interval, the closed interval, a comma b. Then let R denote the region bounded above the graph of f of x let's see. Let R denote the region bounded above the graph. Hold on a second. Did I write that right? Yeah, that's right. So let R denote the region bounded above. Hold on. The region by the graph. Okay, I knew something wasn't right. By the graph. Okay, so let R denote the region bounded above by the graph of f of x and below by the graph of g of x. And on the left and right by the lines x equals a and x equals b. So if you look at your notes and you see that picture that I drew before, that's pretty much what they're setting up. That's what they're saying. If you have something like that, where a region you're bounded above by one graph and you're bounded below by another graph, and then on the sides by two vertical lines, x equals a and x equals b, notice the boundaries of the closed interval, that's what they're referring to. Then the area of R is then given by this integral. The integral from a to b, the endpoints of the closed interval, and by this expression here, f of x minus f of g of x, right? So basically this is the integral that we end up with. So this is what you're going to use to find the area between two curves. So next we're going to do some examples, and we're going to apply this and get some practice. See you then.